Hello, in this video I'm gonna discuss about the time complexity of merge sort. So I'm taking an example, the input value having 8 number of elements, and these elements we will be performing here merge sort algorithm in order to understand how we are getting the time out of it, like how we are going to find out the time complexity. So the merge sort algorithm says that you divide the array into some sub problems and then merge them. So you have to divide this recursively. You will form a recursive tree, divide the tree. For example, this array having 8 elements is divided into 2 parts. Each of them is having 4 number of elements. Now these 4 elements would further be divided into two elements, like the list having 2 elements and then the list having 2 elements, then the list having 2 elements and then the list having 2 elements, and further these 2 elements will also be divided until we reach just one unit element. We are not going to stop until we reach one unit, the single element. So here we have divided this, and now we're gonna merge it. So in dividing it will take some time, and in merging again it is going to take some time. So these are the number of elements that we got after dividing, and we have to merge it. So to merge this, we will compare 2 and 3, whichever is smaller, put that here, and after that the bigger one will come. And then same way we are doing for all of the list. And let's count the number of operations here. So if I take this row, then we'll compare 2 and 1 and take the smaller one is 1, and 1 comes here. And then since I have taken 1 from this array, so increment the pointer of this array, and now 5 will be compared with 2. 2 is smaller, so we'll take 2 here. Now since I've taken 2 from this list, then increment the pointer which is pointing at 2, and after that it will be pointing at 3. Then we'll be comparing 3 and 5. So whichever is smaller is taken up here. 3 is smaller. Now again I've taken 3 from this list, so increment the pointer here, and this pointer is going to point at infinity value, and we'll compare infinity with 5. 5 is smaller, so 5 will be taken here. If you closely see this, in general there are 4 comparisons made out here. Firstly we compared 2 and 1, then we got 1 is smaller, then we compared with 5 and 2, we got 2 is smaller, then we compared 3 and 5, we got 3 is smaller, and then we compared infinity and 5, we got 5 is smaller. So there are in total 4 number of operations being performed. Number of operation, the operation is comparison operation, so it will take, it is taking 4 time. And if you do this, then in worst case, any such, like in this one also and this one also, if you take this one, it will also take 4 operations. So in total this row is taking number of operation as 8, because 4 this plus 4 this becomes 8. This row will also take 8 number of operation in worst case, and these two parts is also going to take 8 number of operations, 4 from this and 4 from this part in the worst case. And so we have number of operations as 8 at each the states, like at each of these levels. Now if we consider this 8 as n value, then replace this with n. Let's say this number of operation, this number of elements are n, and so it becomes this 8 number of operation becomes n. So we are replacing this. So let's consider time complexity to be t of n, and what could possibly be the time complexity. So what we did was that we divided this array, and then that subproblem again got divided and we merged it. So this is the only time that is taking. So in merging I already found it out to be n, order of n it will be taking for merge. And to divide it, let's say this array is divided into 2 parts, so like something like this, it is divided into 2 parts. So it will take some time, and it will take some time, and I have considered this list of n size. So this size is going to be half n by 2, and this size is also going to be n by 2 time. So time taken from this side and from this side going to be same, because this is divided into same sub halves, so it is going to be t of n by 2. So the time is t of n by 2, both of the sides. So total time adding merge time also becomes 2t of n by 2 plus the merge time. And now you can solve it using applying Master's theorem, and this is the Master's theorem for the recurrence relation. Tn is equals to atn by b plus theta and per k log per pn, and a should be greater or equals to 1, b should be greater than 1, and k should be greater or equals to 0, where p is a real number. And in our case the recurrence relation is 2tn by 2 plus order of n, so a is equals to 2 and b is equals to 2, n is equals, sorry, k is equals to 1 here. In if we see in this recurrence relation, I'm talking about this, a is equals to 2, b is equals to 2, and k is equals to 1, and p is equals to 0, because there is no log here. So this is the value, and this is the master theorem. Like, you have to compare a is equals to b per k. If it is, then I mean, if this falls in this case, then we have, and also if we p is equals to 0, then it means that p is greater than minus 1. So take this case. So this is the formula, and you have to put on these values on this formula, and you'll get order of n log n. So this is how we find out using master theorem. Anyways, this is the time complexity of merge sort, and this is the time complexity in best case, average case, or in the worst case scenario, and all of them will take the same time, be it ascending order, the input, if it is in ascending order, or in descending order, if it is having same number of elements, it is going to take order of n log n, not more than that, because all the thing that we have to do is to like divide this part and then merge it. So whatever is the number of element, it is going to take same time complexity, order of n log n. So I hope that it has helped you. Thank you.